scholars, it's Mrs. Gregerson. Hopefully you're having a good 5th day of e-learning. Here's my biggest advice. Even if you're going to procrastinate on my homework and you do it later in the day, I would still advise reading it through in the morning, because I'm going to use what are called Zoom meetings, and I'm going to do live review sessions and answer questions on homework. But normally they're going to be like in the mid-afternoon. So like maybe doing your math homework sooner than later is going to be very helpful, because I will be giving you URL links that will allow you to log in, and we can have a live session of me helping you guys. So please, please, please make sure you're reading through your lessons, at least going through and look for key details before you even have to do it sometime in the morning, and that would be very beneficial. Also, when we're working with this, as this does not want to like erase again, this is actually the start of Unit 4. So working with the rational functions and working with the polynomial functions and graphing them, that's kind of like a Unit 3, and it was a really small session. So we're working with conic sections, and it's really what it is. It's the intersection of a plane and a right circular cone. We call that a cross section, okay? When in geometry, it's like when you slice a 3D figure with a plane, what do you get as a two-dimensional shape? And the ones that you're going to be working with are going to be a circle, and you learned this in geometry. So we're going to be using circles. If you slice a cone in an angle, you are going to end up getting what's an ellipse. You used to call it ovals when you were younger, and we've worked with parabolas quite a bit with graphing them, but we're going to be doing how to take things in general form and change them into standard form, and talk specifically about their vertex and their focus and their directrix. And then we're also going to be working with hyperbolas, because a lot of times when we put two cones exactly on top of each other, we'll have a plane intersect, and we have special rules about this as well. So a few things I just want to go through the definitions of these 4 different shapes we're working with, and you'll see how it visually gives you an idea. The first one says, a circle may be defined as the set of all points in a plane that are equidistant from a fixed point in the plane. So here's our fixed point, and then all the points around it are the same distance away. Well, that same distance away we know is the distance of the radius, and so then we go all the way around. All right, next one is a parabola, and it's the following. It says a parabola may be defined as the set of all points in a plane that are equidistant or the same distance from a fixed line, and by the way, that fixed line is called a directrix, and a point which is the focus. So an idea of, here's our parabola, you would have a directrix right here, and here's your focus, and if I have a point here, it's the same distance away as the point of the line here. I do not have a good drawing ability on this, but that's the idea behind that. And that says the next one is an ellipse may be defined as a set of points in a plane whose the sum of the distances from the 2 fixed point in the plane is constant. So here's 2, and this would be called the foci, and I would be going the same distance around them, which means if I went from here to here, I would always have the same distance. You can almost picture it like if I had a string at the end of these 2 points, and I just kept that string taut and I went all the way around, it would make an ellipse. And then the last definition is the hyperbola is said to be the set of all points in a plane, the difference of whose distance from 2 fixed points in the plane is constant. So when we're working with this, and we have our other one like this, the difference between those 2 points is always going to be constantly the same between the 2. All right, so here's just another picture showing you those, and this would be our circles. And we're going to start with the easiest one first, which is a circle. And just remember, the circle is so simple because all you really need to know about a circle is its center, and you need to know its radius. So I know how far away all my points are going to be. So here's some common characteristics that you need to know about a circle. For instance, this one says both of my variables are going to be squared. If not, this doesn't work, because remember, the area of a circle is actually built off of the distance formula. Also, your coefficients in front of each one must be a positive one. Or I should really say they both can be, I wouldn't really want to say -1, but they need to be the same. All right, so they have to have the same coefficient. Also, they're always going to be positive, because if they're not positive, we'd get a different type of shape. And the other thing is, after you're using completing the square, oh yes, I just used that word, completing the square, your radius will always be positive. All right, so working with this, you need to know a few things about the standard form of a circle. First of all, when you work with this, it is the following. It is the quantity x minus h squared plus the quantity y minus k squared equals the radius squared. Now, what is so important about this? Well, h and k is your center. H is the x value for the center, and k is the y value of the center. And when we work with it, we also have our radius. And our radius is just the square root of r squared. And it's the positive value of it. And that will always be your radius value. This is also, by the way, it's called the standard form of a circle. Sometimes they will say it's the general form of a circle. Just know if I want a standard form of a circle or something like that, I want it so I can quickly pull out the center and find the radius quickly. Now, here's what I mean by this. You had these before. You might have an example of the equation like the following. I get the quantity x plus 1 squared plus the quantity y minus 1 squared is equal 4. Now this is the standard form of the equation of a circle. Its center is -1, 1. Okay? And its radius is the square root of 4, which is going to give me 2. Now, how did I know that this value was -1 even though this one is a positive 1? Look at the original form. The original form of this is x minus h squared plus the quantity y minus k squared equals the radius squared. So notice, how do I change the subtraction form to a positive 1? Well, to do that, you must subtract by a negative number. So that's how it works out. So this is the same idea like when we did point slope form with lines. So that's where those come from. But then the key thing for you to do is always to graph your center first. So I go -1, 1. Then we go the distance of 2 away, to the right, to the left, up and down. And if I was in class, I'd go dance to the right, 2, go to the left, 2, go up, 2, go down, 2, just to kind of make a point with this. But I'll just do it here. Here's my center. I go 2 to the right, 2 to the left, I go up 2, and I go down 2. And my friends, as much as you possibly can, make it into a circle. Okay? If not, this is really a struggle for me to grade. And I can't, guys, I can't give circles for rounded squares. Okay? I just can't. All right, let me give you another example. Okay, what if we had the following? The quantity x minus 3 squared plus y squared is equal to 9. What would be the center of that circle? Well, knowing it's already in standard form, the center of my circle would be 3, 0. Remember, this comes out opposite because of the subtraction sign. And this one had nothing with it, so that meant it was y minus 0, and y minus 0 is y. And then what is going to be our radius? Well, our radius is the square root of 9, which is equal to 3. So I go and I graph my point at 3, 0, and then I graph my 4 points to draw my circle in better. So we have to go up 3 and down 3. And notice you can go either way, and this would be like 2, 3 over here, and we'd have 3 over here. Oops, my circle is looking pretty bad here. That would be your circle. Please draw better than mine and draw to scale better. So hopefully that's a quick reminder of how to do this. Now, you might be asked to write an equation. What if I give you the radius of, let's say, 2 root 2, and the center of 4, negative 5. What would be the equation of that circle? Well, the equation in standard form would be the following. Here's my h, here's my k. So I'm going to go x minus 4, that quantity squared, plus the quantity y minus negative 5, so that would be plus 5 squared, equals my radius squared. Well, remember that's 2 root 2 squared. Well, 2 squared is 4 times the square root of 2, which is 2. That would be 8. And so this would be your equation of that circle. So use that information to help you. But now I want you guys to look at the next 3 problems. Do you notice they're not in standard form of a circle? So what do we do in that process? We use our skills of completing the square. So we have to complete the square. We're not going to solve all the way. We're going to use the skills of completing the square in order to do this. Now, my friends, I need you to add some directions that should go right above all my examples here. So let's use a different color. So let's use the directions. Okay, here's my directions. We're going to write the equation of a circle into, and we're going to call it standard form. Oops. So that's going to be the quantity x minus h squared plus quantity y minus k squared equals the radius squared. And I want you to identify the center and the radius of the circle. Then graph it. So we're going to do a lot of work with this one, but a lot of it you're going to find out you have the skills really already in place to do. So first things first, obviously this is not in standard form of a circle. It's in, notice we got x's together, we got y's together, and that's actually what you want to do. You want to put your x variables together and your y variables together, but we need to work with it from there. So the first thing you would do, if you had a constant on the left-hand side, you'd move it to the right. Well, notice they already did that. But I have an x squared and I have a y squared, which tells me I actually have to do the process of completing the square twice. So the first thing you do is you're going to rewrite your problem like the following. I'm going to do this. I'm going to go x squared minus 4x plus blank. So what I'm going to do over here on this side, I'm going to go negative 9. I'm going to go plus blank for that one. Then I'm going to go plus the quantity. I'm going to go y squared minus 6y plus blank. And I'm going to have to go plus blank over here because really what I'm going to do is I'm going to do it to both sides of the equation. So what do we do first? Well, remember with completing the square, once you have your x squared and your variable together, you divide this by 2. So I get negative 4 divided by 2, which is a negative 2. And then you square the negative 2 and put it in. So I go plus 4. Notice I put a plus 4 in on the other side. Then I look here at that negative 6 and I go negative 6 divided by 2, which is negative 3. And then I square it and I get 9. So I add 9 to the other side. Now, my friends, I need to simplify this as much as possible. So on the right-hand side of the equation, I get negative 9 plus 4 plus 9, which gives me a positive 4. On the left, I am going to rewrite what's now a perfect square trinomial as a binomial squared. This is just like when we were using completing the square before. So with this one, we're going to put in an x minus 2. Remember that negative 2 there? That's what goes in here. Then we're going to go plus. And then we're going to put in our other value here. We're going to go y, and it's going to be minus 3. And that's going to be squared. And you have to have the squareds there or you do not have a circle. So be very careful not to drop those values or it will be considered wrong. when you're doing this. So this is my standard form of the equation of the circle, which now I should be able to pull out my center, which, by the way, remember, it comes out the opposite values. That would be a positive 2, 3. So my ordered pair, and it's an ordered pair. I use C for center. You could go off to the side and just write the word center if you want. It doesn't really matter as long as you have what it is. So the center would be 2, 3. So I go over here, 2, and I go up 3. All right. So 2, 3. Then my radius is the square root of 4, which is 2. So I have to go up 2, down 2, right 2, left 2, and this would be my circle. Do you guys remember doing this a little bit? My students in Geometry Advanced had did this before, and I know college algebra kids did a lot of completing the square, but I'm pretty sure a lot of you got the basics or at least worked with it before. All right, so let's look at the next one. Notice this first example, and then the one that says number 5 here. The leading coefficients, the coefficients in front of your x squared and y squared are both positive. They're both 1. In this case as well, you are given an 8x and negative 2y, so that makes a difference. So now we're going to start the process again of completing the square. And remember, we've got to move this 8 over. We don't want the constant over there. So remember, you're going to get a negative 8 over here. Then we look at our value and we plug it into parentheses. So we get 8x plus blank parenthesis plus, and we're going to go plus blank over here because I have to add on both sides. And then we're going to go for a y squared, not change the color I wanted to. We're going to go in red, so we get y squared minus 2y plus blank, and we're going to go plus blank. Okay, so now we go back to what we know. We look at our, it's really the B of a quadratic formula is really what it is. So we took 8, we divide it by 2, and it's a positive 8, so we get a positive 4, and that positive 4 is being squared, which is 16. We have 16. Then we take this negative 2, we divide it by 2, and that gives us a negative 1, and we square it, which gives us a positive 1, and we add a positive 1 to both sides. So when we're in process of doing that, what do we get on the right hand side? Yeah, we get a negative 8 plus 16, which is 8, plus 1, which is 9. Then we're going to write our two binomials because we want to change it to standard form. Now, what do we put in the first one? Remember, we divided a positive 8 by 2, so we got positive 4. So this is going to be an x plus 4. Our value for y is going to be negative 2 divided by 2, so that gives us a negative 1. So we get y minus 1. Actually, I was going to change colors with that, so let me do that. But still y minus 1 no matter what color it is. And this is our standard form of the equation of a circle. My friends, what is going to be our center? Well, our center, that's going to be a negative 4, 1. Remember, it comes opposite of what we have inside the parentheses. And our radius is the square root of 9, which is equal to 3. So we go over here to negative 4, positive 1, and then we do the radius of over 3. So right 3, left 3. We go up 3, and then we'll go down 3. And so it looks something, let's see if I got this here, like this as a circle, with the center at negative 4, 1. So hopefully it's making a little more sense. I got 2 examples left. This one is like one of your lower problem ones, like 22, 25, 21, somewhere like towards that direction on your homework. I will also post a video of working out 4 homework problems in this assignment. So at the end of the lesson, there will be help videos is there as well. But notice the difference between number 7 and 5 and 1. If you look carefully, you notice that there is a 2 in front of the x squared and 2 in front of the y squared. Well, my friends, you have to get rid of that. So the first thing you're going to do is you're going to divide everything by 2 to get rid of it. So the whole thing divided by 2. All All right, actually, I don't like writing it that way because that's not really true math. It's really doing this. And we get x squared plus y squared minus 4y plus 3 is equal to 0. So here's a few things you need to remember. First, you're going to move the constant over. Then I'm looking over here at my x squareds and my y squareds. Notice you only have an x squared here. Well, you know what that means? You do not have to do completing the square because that really means you have an x minus 0. So since you don't have like a 2x or 5x or something like that, you are done. So this, don't have to do the completing square on the x. However, I do need to do it on the y. So we go y squared minus 4y, and we're going to go plus blank, and we're going to do it on this side. But again, why don't we touch that one? Because if there is no variable to the first degree, x to the first degree, that means 0 is its value. You're really doing this. Okay? All right. So now we do the completing square with the negative 4. Well, what do we do with the negative 4? You divide it by 2 and get negative 2. The negative 2 squared is a positive 4. Now we simplify. So I get x squared plus the quantity, and that's going to be y minus 2 squared, because remember we took the negative 4 divided by 2 and it gave us negative 2. And the negative 3 plus 1 is, negative 3 plus 4 is 1. So this is our equation of the circle in standard form. Its center is at 0, 2. Its radius is at 1. All right, now let's graph. Our center is at 0, 2. Oops, wrong direction. I went to negative 2. Haha. Positive 2. And then we go up 1, down 1, right 1, left 1. One of your easiest circles that you could draw. All right, I have one more I want to write in on here. This one I also want you to write in standard form and pull out the center. So let's just do extra example here. What if I gave you this one? 1/9 x squared plus y, oops, totally forgot what I was writing here. 1/9 y squared is equal to 1. Now that doesn't look like a circle in standard form, and it's not because I have a coefficient out front. Now, when we had 2 as the coefficient out front, we divided everything by 2. And you couldn't think of the same thing like, oh, I'm going to divide everything by 1/9. Well, that's the same thing as multiplying by its reciprocal of 9. So what I'm going to do is get rid of the fractions and multiply both sides of my equation by 9. And when I do that, I get x squared. Actually, I'll write this in a separate step so it's a little bit easier to see what I'm doing. I got 9 times 1/9 x squared plus 1/9 y squared equals 9 times 1. And when we distribute, we get x squared plus y squared is equal to 9. So your center ends up being 0, 0, and your radius is the square root of 3. I'm going to draw it right here on this one. So my center is at 0, 0, and my radius is 3. So we go here, all 4 directions. The distance is 3, and that would be your circle for this last example. All right, guys, like I said, I'll give you 4 examples of some of the harder problems or unique problems on the homework. Definitely use it after you're done trying to do the homework and you corrected it, and you can go back and fix it before you submit it. That's totally okay with me. Thanks for listening. Hope you're having a happy e-learning day.